Howdy ho to all the grade 9 students in my class. Again, I hope you're all doing well. Um, I know it's not the same having to do these questions over the internet and having to do them via YouTube, but it's not the end of the world. It's at least something. It's keeping you guys focused on your math. And for all of you next year when you go into grade 10, all of these concepts are key for success. So hopefully the better you master them now, the easier it's going to be to transition into grade 10. So our first question here in chapter 2 comes from rational numbers. It says solve and show all your work. So it's basically a grade 8 question with fraction operations. It's an operation question. The only difference is we have negative fractions, which is something you didn't do in grade 8, but we did do in grade 9. So the first thing we're going to tackle here is we're going to look at our multiplication. Okay, so I'm going to bring down this part here. It's at negative 1 1/5 plus whatever the product is. And I'm simply going to rewrite negative 2/3 by putting my negative symbol in my numerator. I told you it's always easiest to keep it up there. I'm going to multiply that by negative 3/2, which is the improper fraction of negative 1 1/2. Now at this point you can do one of two things. You can simply multiply your numerators and multiply your denominators, or you could cross reduce if you want. For purposes of simplicity, I'm just going to multiply negative 2 by negative 3 to get 6. I'm going to multiply 3 by 2 and get 6. And I end up with a positive 1, or 6/6. If you see 6/6 as being 1, then this next part's not going to be very difficult at all, because negative 1 1/5 plus 1, if I said what's negative 1 plus 1, you'd say it's 0. But negative 1 1/5 plus 1 is negative 1/5, or negative 1/5, or if you really want to get fancy, negative 0.2 if you want to put it as a decimal. But that's all the work you really needed to show for question 1. If you didn't get that question right, press pause, make a note on a piece of paper or on the paper you did your questions on what you did wrong, and hopefully the next time we have a question like this, you won't make that mistake twice. Press pause if you need more time anytime. Question 2, we have a string of 4 exponential forms, or 4 powers, and we're asked to add or subtract them together. So the first one is the trickiest one of them all. It says negative 2 exponent 4. And remember that we said before that this and this are not the same thing. If you have what appears to be a negative base not in brackets to an exponent, then the base is not negative. It's simply the opposite of 2 to the exponent of 4. Or some people like to think of it as being an invisible 1, right? So the opposite of 2 to the 4, well, 2 to the 4 is 2 times 2 times 2 times 2, which is, I'll write that down, 2 times 2 times 2 times 2, which is 16, and therefore negative 2 exponent 4 is negative 16. Takeaway, now in the next one we have negative 2 in brackets to the exponent of 0. And we said before that any base to an exponent of 0 is 1. So in this case, it's still going to be takeaway 1. It's not a negative 1, it's a 1. So negative 2 to the exponent of 0 is 1. Plus, we have 1 to the exponent of 10, which means it's 1 multiplied by itself 10 times, and 1 multiplied by itself any number of times is still 1. And then we have plus, the base is negative 2 in brackets to the exponent of 1, and any base to an exponent of 1 is itself. So we have plus negative 2 here. So when we simplify all those, we get negative 16, take away a positive 1. If you want to keep that in brackets, take away a positive 1. Plus a positive 1, plus a negative 2. So negative 3 take away a negative, or take away a positive 1, is actually going to be negative 17. And if we wanted to keep flip change, if you wanted to do that, you can. Plus 1, plus negative 2. Negative 17 plus 1 is back to negative 16 again, plus negative 2. And we end up with negative 18 as our solution for this problem. Question 3 comes from chapter 9 on adding and subtracting polynomials. This one is a trinomial, because it has 3 terms. Take away another trinomial. And I said in the instructions on Wednesday that this was a little tricky in that I did not order the terms in descending degree of value. So the first thing we're going to do is we're going to realize this is a subtraction. And just like if I gave you the question negative 4 take away negative 3, what we learned to do as an easier way to do the question was change to addition and use the opposite of the second term. In this particular question, when we're doing polynomials, that same thing is true. We can change it to addition and use the opposite of every term in the second polynomial. In this case, every term of the 3 in the trinomial. And once we have that switched over, we're going to start gathering like terms. And remember, in order to gather like terms, they have to have the same base and the same exponent. So a positive 2x squared and a negative 8x squared, excuse me, is going to be a negative 6x squared as when you gather those two terms together. A 4x and a negative 4x are going to make nothing. And a negative 3 and a positive 6 are going to be a positive 3. Now at this stage here, you cannot simplify this any further because x squareds and just constant terms are not like terms, and you can't gather them past that. So our solution to the trinomial plus the other, or take away the other trinomial, would be this binomial, negative 6x squared plus 3. Our next question comes from chapter 7, and it's on multiplying and dividing polynomials. On Monday, we gave you a question with multiplying a trinomial by a monomial, and this is division of a trinomial by a monomial. So every term in this trinomial must be divided by negative 5. And when we first worked this out, we said sometimes it's easier just to write down each term divided by negative 5, right? And I think to myself, well, what is 10x squared divided by negative 5? It's negative 2x squared. What is negative 5x divided by negative 5? It's a positive x. And what is 15 divided by negative 5? It's negative 3. And again, just like the last question, I now have a trinomial, but I can't take it past this trinomial because there are 3 terms, and none of them are like terms, because even though they're x's, you can't add an x squared to an x because they're not like terms. You can multiply them, but you can't add them. So our final solution for this would be negative 2x squared plus x minus 3. In question 5, we have an algebra question. It's fractions, and just like Monday's question, we said that sometimes you could either multiply both sides by a common multiple of the denominators of every term in the equation, or you could approach it from an opposite operation standpoint and get rid of your constant first and then your coefficient. And in this particular question, that's probably the easier way. So the first thing I'm going to do is going to choose a pen that works. I'm going to subtract 5/8 from both sides. Here it's going to create a 0 pair, and I'm going to be left with not 2x, but rather negative 2x. And now that we have this here, I'm going to erase this here. I'm going to grab this and bring it up here. If I'm going to subtract 5/8, I should subtract that. Subtract 5/8 from this. Because this is a mixed fraction, I'm going to change it to 33/16, take away 5/8. And we know that when we subtract fractions, we need common denominators. So I'm going to pull this one down a little bit. I need a little bit more room. Common denominator will be 16. 33/16 is going to stay 33/16, but 5/8 is going to become 10/16. And 33/16 take away 10/16 is 23/16. Okay? That's our first step. So we got rid of our constant term, and now we have this coefficient to get rid of. And back in grade 8, you would have divided by negative 2 to get rid of it to leave you with x. But if you divide this side by negative 2, you don't want to show it like this. Because it's a fraction, oops, my 16 is gone. You want to divide it by negative 2. And since it's a whole number and you're dealing with fractions, we said before it's probably easier to think of it as being negative 2 over 1. So now that we have that, we ask ourselves, well, how do I divide fractions again? What's my procedure for this? You're going to keep your first fraction, and you're going to change to multiplication by the reciprocal. Notice how I just kept my negative sign in the numerator, even though it was with the 2. It's still a negative half when you reciprocate it, and it doesn't matter where you put your negative symbol. It's just easiest to keep it in the numerator, I find. Now that you have multiplication, multiply your numerators, multiply your denominators, and you end up with negative 23 over 32 as a solution. Now that's a lot of work, so if you want to, I'll just hang on a second. Entire page. If you want to copy that down, press pause and copy it down, you can. And our second last question, sorry, we have a linear relationship too, is our inequalities from chapter 6. It says 10 is less than the value of 14 plus 2x, or alternatively, if you wanted to read it on the side from the variable, You could say 14 plus 2x is greater than the value of 10. So we want to isolate for x just like we would with any algebra question. And in order to do that, we're going to get rid of our constant term first, leaving us with 2x is greater than negative 4. We're going to divide both sides by 2. We're left with x is greater than, or all terms greater than negative 2 would satisfy the inequality. Now remember last day on Monday we had to flip the sign. That's because we multiplied or divided by a negative value. Here we divided both sides by a positive 2, which means we do not have to flip the sign. And our last step is to write it on a number line. I'll put negative 2 here. I'll put negative 1 here. I'll put negative 3 here. And remember, we read from our term, our variable term, all values greater than negative 2. All values greater than negative 2 is an open boundary point because it does not include negative 2. And any value greater will be this way on our number line. I'll use red this time. Any value to infinity that's greater than negative 2 will satisfy that inequality. And finally, your last question on the linear relations, and I know we didn't get a chance to correct these prior to March break, but it's okay. If you forget how to do them, just listen, and hopefully it'll jog your memory, and you'll be like, oh yeah, I remember how to do this now. So there is an equation that matches all of these ordered pairs. This first ordered pair is 10 for the x, negative 2 for the y, 8 for the x, 2 for the y, 6 for the x, 6 for the y, and 4 for the x, and 10 for the y. And if we were to graph those on a graph, it might look something like this. Okay, a straight line. And we said that any points, these 4 points, plus any other points beyond here, which we called extrapolation, or any other points in between here on that line, which we called interpolation, would be values that would still match that equation of that line. And how to find that equation was to find the difference in y, or your slope, divided by the difference in x. So the difference in y, it goes from negative 2 to a positive 2, which is a positive 4. And it goes from a positive 4 each time. And from 10 to 8, it goes down by 2 each time. So the difference in y, which is 4, or positive 4, divided by the difference in x, which is negative 2, a positive 4 divided by a negative 2 is a negative 2. Now what does that mean? Well, in the equation that shows the relationship between x and y, negative 2 is the coefficient of x. Okay? Now once we have that, that might be our equation that shows the relationship between each pair, but it probably isn't, because most of these linear equations require a constant. So in order to figure out if it needs a constant or not, you can take any ordered pair. You can take this one, or you can take this one, or you can take this one, or you can take whatever one you want. I'm going to choose the first one, which is 10 and 2. And the x is 10, and the y is 2 in that first ordered pair. So I'm going to substitute that, x is 10, and y is negative 2, right there. I'm going to simplify this expression to become negative 20, and I'm going to ask myself, is negative 20 equal to negative 2? And because it's not, and because we are using an equal sign, I have to use a constant term to make sure that both of those sides are equal. And this time, if I add an 18, I end up creating an expression, an equation that shows all of the relationships between x and y in all 4 of these ordered pairs, and any pair beyond that through extrapolation, or any pair in between there through interpolation. So this is the equation that matches it. And just to show you that it is, just to remind you, I'm going to take this pair right here, 4 and 10, and I'm going to take my equation, which is negative 2x plus 18 equals y, and I'm going to substitute 4, which is the x value. I'm going to substitute 10 for the y value, and when I simplify it, I'm going to see that 10 is equal to 10. So the x value and the y value in that equation do keep balance, and they are equal. So that is the equation, negative 2x plus 18 equals y. All right, stay safe. On Friday, tomorrow, we will have just one question tomorrow for our math. It's Easter Friday, so if you do it, it's great. If you don't, because you're on holidays, you don't have to do it, but it will be provided. We will continue math again on Tuesday, because Monday is a holiday as well. So on Tuesday, we will have our next Reachback with different types of questions. We're going to try and keep it not so boring by doing the same thing over and over again, but we are going to keep it from each chapter. And hopefully this will help maintain the skills you've acquired so far this year. Thank you guys for who have emailed me back with your answers. And if you haven't emailed me back, please make sure you send it to my edu.pe.ca account. Stay safe, people.